Hello, my name is Genevieve Wisby, and I will be presenting the automated life testing device for the Sterizone VP4. The sponsor for this project was Stryker, the sponsor contact was Brianna LaBelle-Hahn, and the faculty advisor was Dr. Wendy Reffer. The team that worked on this project was myself, Genevieve Wisby, Malcolm McDonald, Jacob Arns, Josh Fogley, Eric Guo, and Dylan Matthews. The task of this project was to design a machine to autonomously run the Sterizone VP4 sterilizer with minimally human interaction and until the VP4 fails. The VP4 is a dual-sterilant, low-temperature sterilizer that uses vaporized hydrogen peroxide and ozone to sterilize medical instruments. Some key terminology about the VP4 critical to our machine is the door, which is what opens and closes to access the chamber. The chamber is what does the sterilization, and the rack is what slides into and out of the chamber that holds the medical instruments. Due to the length of the cycle and the cool-down time required, the current testing on the machine does not allow for the entire cycle to be completed, the door to be opened and closed, or the rack to exit the chamber and re-enter after cooling. The next video I'm about to show is how a current operator would load and unload the VP4, and our goal was to create a machine that replicates this motion. So the loading process. The operator opens the door of the chamber, aligns the rack with the chamber on a cart, pushes the rack into the chamber, moves the cart away from the VP4, closes the door, and uses the HMI to start the cycle. The operator holds the door until the cycle begins. The cycle then takes about 60 minutes to run. When completed, the operator opens the door and moves the cart to the edge of the chamber. The operator then pulls the rack out of the chamber onto the cart. The cart can then be wheeled away for the rack to cool down to between 23 and 25 degrees Celsius to then repeat the loading process. The cooling down time takes anywhere between 20 to 30 minutes. The machine that we created was called the Automated Life Testing Device, shortened to be ALT. We wanted this machine to have minimal human interaction and be able to run for 10,000 cycles, because we wanted the VP4 to approach failure before our machine failed. Some of the main functions of this machine was to start cycles on the VP4, open and close the door of the chamber, load and unload the rack from the chamber, monitor errors on the VP4, and use a two-rack system to allow for quicker cycle times, so one rack may be cooling while the other rack is in a cycle. Some of the big components of our machine includes a scissor lift, 3 conveyor zones, 2 lead screw actuators, and a motor to open and close the door. Some of the critical specifications we had of our machine was a height, width, and length constraint, an adjustable height constraint to account for variations within chamber heights, a life constraint which we needed it to last longer than the VP4. Our machine also had to be portable on wheels in case it needed to be used on a different machine. We also need to sense the temperature of the rack to ensure that we're not putting a too warm of a rack back in the cycle. And we desire to have a 2-rack system for quicker cycle time. The next video that I'm about to show will give an overview of how our ALT will function. So first we're going to open the door of the VP4. We're going to transfer a rack from the storage location and into the chamber using the conveyor systems. The arm will come down and push the rack the rest of the way in the chamber. The arm will get up out of the way, the door will close, a cycle will run. After that, the door will open. The rack will be removed from the chamber using an arm. From there, it will be stored back into its storage location. Then the scissor lift will retrieve the other rack from storage location 2. That rack will be loaded into the chamber. And that cycle will repeat continuously until failure. So let's get into the components of the ALT. The first one we'll get into is the opening and closing of the door. To open and close the door, we are utilizing a 2-phase stepper motor, which is attached to a shaft. The shaft is then attached to the door using a journal bearing. To help control our rotation, we have limit switches that will